with some very simple probabilities in the past. When you're looking at probability, yeah.
Are you collecting that or no? Okay.
When you're looking at probabilities, probability is usually written out as capital P, and it's of some event. And you write it out as a ratio. Ratios are percents, decimals are fractions. Okay? When we do that, you want the favorable outcome over total possible outcomes. Okay? So when you guys are thinking about your deck of cards, when we had the question where how many hands could you be dealt 4 aces and a king, we figured out that out of the 2.6 million, there's 4.
Yeah.
4 over 2.6 million means it's not going to happen. And if it does happen, you're doing rather well. Okay? It's the coin flip. It's 50-50. It's rolling the dice. You get a 2. What do you get? 1 out of 6. It's the idea that I can flip over this card, and I'm going to ask Clay.
We're not going to play again.
I'll pick one.
What's the card?
I'll go.
Oh, 5 of hearts.
Aces.
Ace of spades.
5 of hearts.
5 of hearts? No.
No.
Ace of spades.
Now, third hour,
They got it right.
they got it right.
Oh.
I'm not lying. Cullen,
He's like X-Men.
and he said, ah. And he spit out the thing. I'm like, and he got it right. So, we just said, don't ever go gambling because you'll never do that again. So, what's the probability that he was going to get it? How many cards are there?
1 out of 52.
It's 1 out of 52. So, what's this one?
3 of the dice.
Ah!
Ace of spades. Ace of spades.
Ace of base.
Once this card's messed up, it's you guys have to let. Well, you have a snowball's chance of getting it right.
5 of diamonds.
No, it's still 4 hearts.
You have a
So if we theoretically do this
1.9% chance.
52 times, somebody should get it right, right?
Right.
No.
Because in theory, though,
The more you do, it
in
has
theory,
no effect. Well,
The chance is still
it doesn't affect it at all.
now what is that called? Is that theoretical or experimental probability?
Experimental.
Experimental.
Experimental is if you went through the trials of doing it and checking it every time. Because I'm sure you guys ever do the thing where you flip a coin 100 times and you see, does it actually go 50-50?
No.
No, but in theory it should. Okay, experimentally it might go 52-48. Okay,
Environmental factors.
it's just it has nothing to do with it. Okay,
It's
the
humid,
same-
so Penny, it's more of a 47 to 53.
Last one.
7 of spades.
I don't gamble.
It's not a gamble.
It's a guess.
Guess the same thing.
How about you?
I already know what it is.
So shuffle the deck.
4 of hearts.
You just don't want to lose. You get mad when you lose.
No, I don't.
You have a 1.92% chance.
You get mad.
Wait, what is the card? You have a 1.92%.
So real fast, if you're gonna roll a die, what's the probability you're gonna get a 4?
1 out of 6.
Now, when you see this written out, you're going to see it written like this. Probability of a 4, 1 out of 6. Probability of odd,
1/2.
1/2. I like the fact that you actually simplified your fractions right away.
There you go, guys.
The probability of rolling less than 7, 1.
1%.
Wait, what?
1.
What if you could have said?
What if you have an octagonal?
Because it defined it at the beginning as a 6-sided die.
You roll the dice, it gets lost, and a 7-sided die comes back.
What?
You roll
Not
it.
humorous.
Yeah, I'm laughing.
Nobody cares.
Can your probability of an event, or if a probability of an event is 0, what does that mean?
It's not possible? It's impossible.
Not gonna happen.
So you want to use the place up
Not gonna happen. The probability of some event equaling 1.
Always.
It's gonna happen. It is certain. Like? Such an idiot.
Like claiming the bed joke.
See what I did there?
I did.
Pretty funny, huh? Okay.
Sure.
Now, can probability ever be less than 0?
No.
No. Can probability ever be greater than 1?
No.
Probability is always between 0 and 1. What?
What's that? Why can't it be, why is it not between like 0 and 100? And like, you just simplify the percentages and kind of way.
We're looking at, it's still less, 89% is still less than 1, isn't it?
Yeah. But why did you say that? But like, why did you make it out of 100 so it's just that number is the probability, that percentage?
Because normal people say it's between 0 and 1.
And you're.
Not just calling you I'm just calling you abnormal.
Oh, I
Just,
already know that.
it's just meaning that you're not of the norm.
I already know that.
Everybody's different.
No, one person in the world.
What's that?
How could it ever be overwhelming?
It can't be.
Yeah, I was gonna say like,
You can't have more favorable outcomes than you can have total outcomes.
yeah.
Just doesn't make sense.
No.
Unless you're cheating. What was the thing we were talking about earlier? How do you get 5 kings? You
Yeah.
cheat.
Yeah, that's
I have no cards on my sleeve.
You've never heard of the game bullshit?
I know. What's your language, people?
It's like
Seriously. Real fast, when you're talking about experimental versus, what do you call it? Theoretical probability. A lot of times your experimental probability comes from tables and graphs and charts and things like this. Now, when you're dealing with experimental probability, if you're looking at something very simple like this, and I don't want you to copy all this out,
okay.
this is an experiment of some data. And they want to know what's the probability of selecting a person that's at least 45. Well, if they're at least 45, that means they can be older or younger.
Younger.
Older.
Older, yeah.
Because that's the lowest amount they can be. So the total in this part of favorable outcomes would be those two values added together. Bless you. And then what would be your total outcomes then?
You have no worry.
Divided by all of them. I know that you guys have seen that before. It is not that difficult. Which leads you to the pseudo more difficult stuff.
Yay.
Geometric probability.
It's the geometric
ratios.
I already had.
The ratio. Right. But we're going to do probability with it.
She did that last year.
When you're dealing with geometric probability, you still have, you want to find the area of the favorable region divided by
All of the region.
the total area.
I totally remember these.
Okay? So for example, if I want to find the probability of hitting the bullseye, I'd have to first of all figure out and calculate the area of the bullseye. Well, it's nice and convenient that it is a
Circle.
How do you find the area of a circle?
2 pi r.
That's circumference.
Pi r
No, it's not. It's round. That's still
squared.
circumference.
It's the same thing as 2 pi r.
that was funny.
You said the same thing as me.
Pi r squared. So if I know, but someone else yelled 2 pi r.
That wasn't Clay.
I know. So the area of the favorable circle has a radius of 3. What would the area be?
I don't know.
9 pi. Very good. Now the total area would be the large circle. So, Lily, this one's for you. 3 plus 1 plus 2 plus 1 plus 2 plus 3.
1 plus 2 plus
12. So what is the area of a circle with a radius of 12? So you wind up with 9 pi over 144 pi.
It's kind of sad that I could do 12 squared.
Oh my god. Oh my god.
Oh, no. Don't miss.
Wait, you have a 6.25%
Oh, look at that.
Don't miss an again.
You have a 6.25%.
Benjo, you might want to get behind a plexiglass window.
You have a 6.25% chance of being
Wouldn't the distance, the farther you go back,
Yeah,
the probability less?
I've seen people throw darts.
It doesn't matter. I just
Yeah, how does that work?
back
How does that exist?
Yeah, the probability.
No.
Okay.
You guys realize it's a piece of plastic with a string?
Mr. Murphy, let him do it.
No.
Did you steal that from your children?
No, I bought it.
You go to Five Below.
You gotta back up.
Oh, you slug.
Might as well follow it out while you're
Do another one.
You had a 6.25% chance of
Yeah, it doesn't work. It doesn't work always.
Nope.
You suck.
Just try to hit one of the options.
Ooh, try that coffee. See if you can.
You shot all three darts from different distances.
You somehow got only red the entire time.
Ah, what's the geometric probability of getting just red?
Oh my god.
Why did you say that? Ah.
Oh, I'm not.
You'd have to find all those shaded regions there. Ooh.
I got it.
Better if I shoot like a
They have a
crossbow.
suction cups for a reason.
Well, this didn't get all shaded. Wait, can you call the arrow?
He's gonna be good for us.
I want to make it first.
Wait, back up.
I'm not backing up. I'm trying to make this work.
Brad, he plays. I'm actually
You didn't even make it. Count that as green. Okay.
It didn't work.
We'll have to watch the video. You cannot see this.
There, now it worked.
I am the champion, no type of noodle, but I am the champion of the world.
Can you just give me my homework?
Oh, I sounded.
How long?
I forgot about that.
It works. It works. It works.
That is so offensive. Winning is winning. No matter what happens.
I'm doing good. I'm just working and I'm shooting. Bow and arrow.
I think it's 14 through 29. These sound like a bunch of dead cows. Is it 14? I don't remember if it's ever 14.
I don't think he's ever trouble working.
Oh yeah, you're right. Does it? Dead cows don't make sounds, do they?
I usually not what you've done.
Even joke about that cow. She was singing to me.
Pretty sure that doesn't make much sense, does it?
So it's not a
It's 12 through 29. 12 through 29.
Oh no, Christian has the same one. He plays another one too.
I was close. We'll do more geometrics. Geometric can get messy. I want to make sure you guys get good at it.
Any idea, like, around what the might be?
Not a clue.
Would you draw my son of a bitch?
Mr. Murphy, do you want me to erase your board?
Yeah, you can. Thank you.
No, we're
Mr. Owens, it's 12 or 13.
12.
We have practice.
Come on.